Hello, I'm trying to design a multi-tool from scratch, so I'm gonna share today what's the current update on that journey. The idea is, can we make a multi-tool that has pliers and other accessories, but only using 2D parts, kind of things that can be easily laser cut? You may ask why. Well, the reason is um, 2D machining is very easy to customize. So if you wanted to make your very own multi-tool, this may be the way to go. If you could cut flat pieces and assemble it in a multi-tool, that'll be, I think, easier to customize. So that could be the future of multi-tools in terms of innovation. Some tools already use a lot of flat plates. For example, this one from Martin has a lot of flat plates that are probably very easy to design and change, modify. I think it's much less work than doing like those 3D pads for CNC or CAM, if you wish. So there is some simplicity about using lots of 2D shapes that already have a standardized thickness. So one of the hardest parts to do with flat pieces is the pliers. Because the pliers are very 3D. You have this hinge, which is usually machined. It's not really something super flat. You have the crossing of the two pliers, so that's always made very three-dimensionally. However, there's ways to stack flat plates. I did first some tests with paper, so you could stack flat plates and make a plier shape. And then I did a very crude metal version that shows that you can get that action. However, this doesn't have the right force and such, because you would need something to hold the pliers. So at this stage I was investigating how to hold the pliers so you can apply a little bit of force. And if you look at some tools like the Gerber suspension, it takes only a small piece of metal pushing into that flat part to hold the pliers. So you don't need really a lot of material. You just need a piece that is just in the right place. So what I did is I 3D printed a bunch of parts, and I worked on this problem of the pushing the pliers. So this is a flat piece that attaches to the handles through its notches here. So when that flat piece will match with a part in the plier head, and then you can apply force. So this solves the second problem I had, which is applying force. And then here I printed some mock-up tools, and these have a little thing to get them out. So I'm pretty happy with the result, because now you can apply force to the pliers, and then you can also fold it into a compact shape, only using flat plates. The way I build these flat plates is by 3D printing. This is an example of the 3D printed parts. So this would be the plier head, which is made by layers. Some layers are incomplete. That allows for the crisscrossing of the plier head for the action. And then these are the handles, and this is the bar that will apply force to to the pliers, and these are the tools, and the other end of this bar will keep the tools in place when they are open. So it's not a lock per se, but at least they don't just go all around. So you have this little notch there that will match with that bar. It took some thinking to make this work because you need certain clearance here. It wasn't too obvious how to do a good shape that lets you open wide, apply force, fold it. Everything has to work just so. So I did a bit of math and also kind of geometrical thinking. Basically, there are certain angles when the plier is closed. You have a certain angle, so you can apply force and things of that nature. So this is a really fun exercise to do, and not super obvious to me how to solve it initially, but a couple days of doodling and trying things in the computer screen or whatnot, I got something that is pretty much functional. Of course, there's improvements to make. These are fasteners from a hardware store, but you could get low profile fasteners, so lots of improvements. And of course, at some point I maybe order laser cut parts or water jet parts, see if you can get a really strong product. But I'm pretty happy with how this is turning out. I wasn't sure everything was gonna fall into place, but this system basically lets you solve the second problem, and I may continue with this exploration. So, very excited, and thank you for watching.